This video is about radicals with variables underneath. So remember, we know how to use factor trees to simplify square roots. Now we're going to look at what happens when there's a variable under the square root. If the exponent is even, you just divide by 2 and no variable remains under the radical. If the exponent is odd, we're going to subtract 1 and then divide by 2, and the radical with the exponent of 1 remains under the radical. So if it's odd, is going to leave a variable underneath the radical like it did with the w. And when I subtract, I'm left with 10. Half of 10 is 5. Whereas f of 6 is an even number. So when I divide by 6 by 2, I get 3, and there's nothing left under the square root. So in number 1, we have the square root of t squared. Remember that t squared is even. So I'm just going to divide by 2, and I get t to the first, or just t. Number 2, q to the 5th. Well, q is odd, so one of them is going to have to stay under the square root. And when I subtract 5 minus 1 that stayed under, I'm left with 4. So half of 4 is then 2. So I have q squared root q. Number 3 has two variables underneath. It has a g and an f. So the g is odd, which means one g is going to have to stay under the square root. 5 minus 1 is 4. Divide by 2 gets us g to the g squared. F to the 8th is even, so we just divide 8 by 2, and we get f to the 4th. In number 4, k to the 13th is odd, so one of the k's is going to stay under the square root. 13 minus 1 gets us 12, and when we divide 12 by 2, we get k to the 6th. J is even, so we're just going to divide the 12 by 2 and get 6 as well, so j to the 6th. G is odd, so one of the g's is going to stay under the square root. And when we subtract, we got 16. Half of 16 is 8, so we get g to the 8th. Now, 5 starts to include numbers with us. So we have the square root of 49, m to the 8th, n to the 12th. So we're going to treat each thing separate still. So 49, we know the square root of 49 is 7. It's a perfect square, so nothing's left over. M is to the 8th is even, so we're just going to divide that by 2, and we get m to the 4th. N to the 12th is also even, so when we divide by 2, we get n to the 6th. Number 6, we have 5 root 9, c to the 15th, f to the 8th. So we know that the square root of 9 is 3, so we're going to multiply that with the 5 already out there. C to the 15th is odd, so one of the c's is stuck under the radical. So now we're going to do 15 minus 1, which gets us 14, and half of 14 is 7. So that gets us c to the 7th. F is even, so we're just going to divide that by 2 to get f to the 3rd. So our final answer would be 15, c to the 7th, f to the 3rd, root c. Number 7, the square root of 24, p to the 7th. Well, 24 is not a perfect square, so we're going to have to make a factor tree of what multiplies to 24, which is 6 and 4. 6 breaks down to 3 and 2, and 4 breaks down to 2 and 2. So the pair of 2's goes out front. The 3 and the 2 that don't have pairs are left under the radical. P to the 7th is odd, so 1p is stuck under the radical. And we subtract 1 from 7, we get 6. Divide by 3, or divide by 2 gets us p to the 3rd. So when we simplify this, we get 2p to the 3rd, root 6p. Number 8, we need to break down 40. So 40 multiplies to 8 and 5. 8 is 4 and 2, and 4 is 2 and 2. So I have a pair of 2's that's going to multiply outside with that root, with that 9. And under the root, I'm left with 2 and 5 that did not have pairs. Again, p to the 7th is odd, so p stays under the square root. And when I divide the remainder of 6, I get 3. So I get negative 18p cubed root 10p. Number 9, we get the square root of 128, d to the 23rd, f to the 28th, and g to the 17th. So we're going to break down 128 into 2 and 64. I'm going to break 64 into 2 and 32, 4 and 8. 4 breaks down to 2 and 2, 8 breaks down to 4 and 2, and 2 and 2. So I have pair of 2's, pair of 2's, and pair of 2's. All of those are going to multiply out front, so 2 times 2 times 2, and I have another 2 left without a pair under the radical. D to the 23rd is odd, so one of the d's will stay under the square root. 23 minus 1 is 22, and we divide that by 2, we get d to the 11th. F to the 28th is even, so we're just going to divide that in half and get f to the 14th. G is odd, so we're going to put 1 under the square root. 17 minus 1 is 16, divided by 2 gets us g to the 8th. So when I multiply 2 times 2 times 2, I get 8, d to the 11th, f to the 14th, g to the 8th, root 2 dg. Number 10, negative square root of 72, x to the 6th, y to the 8th. So 72 can break down into 8 and 9. 9 breaks down to 3 and 3. 8 breaks down to 2 and 4, 2 and 2. So I have a pair of 2s and a pair of 3s. There's already a negative out front, so we have negative 1 times 2 times 3 with a 2 left under the root. Now, x and y both have even exponents, so we're just going to divide those by 2, and we get x to the 3rd, y to the 4th. So when I multiply my numbers, I get negative 6, x to the 3rd, y to the 4th, root 2. Our last problem, we're going to break down 270 into 90 and 3. 90 breaks down to 9 and 10. 10 breaks down to 5 and 2, and 9 breaks down to 3 and 3. So I have a pair of 3s I'm going to multiply with the 3 already out front. Under the radical, I'm left with 2, 5, and 3. A is an even exponent, so we're just going to cut 8 in half, and we get a to the 4th. B is also an even exponent, so when we divide by 2, we get b to the 5th. C is an odd exponent, so we're going to put 1c under the square root and subtract from 13 to get 12, and then divide that in half, so we get c to the 6th. So we have 9a to the 4th, b to the 5th, c to the 6th, root 30c.